Okay, now members, let us see functions in details. Functions, but before we go to them, let us see what are the types of mapping that we can come across. So one mapping, each element in the domain is mapped onto a specific element in the range. So here in one-to-one, one element to one element, as you see, the arrows are specific. This to this, this to this, this to this. When you come to one to many, here, one element in the domain can be mapped to more than one element in range. It's that this one is mapped to this and this one is mapped to this. So this is one to many. Okay. Then come to many, now many to one. This is domain to range. Here, more than one element in the domain is mapped to some members or to the same members of a range. So now more than one element in the domain is mapped to more to one. So these three are mapped to the same. So here many are mapped to one in the domain, as you see. Many to one. Many to one. Here it was one to now many. Here is many to one. They are converging to one like this. Then many to many mapping, where any element in the domain can be related to any element in the range. You see this to this, this to this, this to this, this to this. So many to many. Now, from there you can easily define now our function. A function is a one-to-one mapping. I think you know one-to-one mapping. Each value is adding a specific value in the range. Related to a specific member in the domain is related to a specific member in the range. It can be written as x to this or f of x is equal to this. There are two ways you can write a function. Now this variable of x can change to y, can change to x, can change to z. So this is just a dynamic variable, meaning it can change anywhere. It can be y, it can be x, and so on. Even this. Just that you need to know a function is the relation between members, specific members of the domain, specific members of the range. Let us see how do we handle the first part. Given that f of x is this, find f of 1. Now, so that our f of x is given by 3x plus 4. Now, if they say f of 1, it means that now f of 1, it means where there is x, you put 1. So where there is x, you put 1. Because they have replaced it with also a 1. This will be now 3 into 1, then plus 4, which will be 7. Which will be 3 plus 4, which will be 7. 1 times 3 plus 4 is 7. As simple as that. When you come to this is Roman number 1. The Roman number 2, you still want to get f of 2. But remember, the original function is 4x plus 4. 3x. So this is 3x plus 4. So now my f of 2, this one, where there is x, you put 2. 3 into 2 plus 4. This will be now 6 plus 4, which will be 10. With this, you just substitute. When you come down to this, you start with our original function. F of x is 3x plus 4. Now, f of negative r third, you put it with its sign b, 3. Now, where there is x, I put negative r third, then plus 4. So when you multiply by this one, you get negative 1 plus 4, which will be 3. So now, that's how we handle them. You just substitute where they are given. This one they are coordinate evaluated a function to get. Now this is the domain. This one, this is the range. This one acts as the domain. Okay, let us go to this one. Now this one is having two variables, x and y. The idea is the same. Substitute the way they are saying. It's that our original x comma y is 4x plus 2y. So what about 8 of 1, 1? It means that where there is x, put 1, where there is y, put 1. So it's going to be 2, 4 into 1, then 2 into 1. This will be 4 plus 2, which will be 6. Simple as that. When you come to manual 2, we have still the original function is what we start with, is 4x plus 2y. Then they are giving me the one to evaluate h to -3. It means x is 2, as you see. This is in the place of x, this is in the place of y, substitute. So 4 into 2 plus 2 into now -3. So where there is x, we put 2, where there is y, we put that. So this will be now 8, 2 times 4, 8, 2 times this, we get to -6. And so this will give us 2. As simple as that. That's how we evaluate them. If they have different variables, you evaluate them accordingly. Now it has this one. Now they are giving us b. You start this one can change. Now b. They want us to get first of all b of 0. You start with our original function. Our b of x is x squared minus 2 over x plus 1. Now, in the place of x, they are putting a 0. So b of 0 will be 0 squared minus 2 over 0 plus 1. Where there is x, I'm putting 0. You see x, the element here, x is 0. So where there is x, you put a 0 also. You leave others, don't mind about others, just leave them in the equation. I mean in your solution, the way they are. Where there is x, I put 0. So this will be 0 minus 2 over 1, which will be -2. As simple as that. When I come to b of 2, this is Roman numeral 1, Roman numeral 2, b of 2. I start with the original function, which is b of x, which is x plus 1. Now my b of 2 will be, now where there is x, I put 2, as you see, x, 2. So I put 2 squared minus 2 over 2 plus 1. When you square 2, you get 4, get 3, which will be 2 over 3 with this, and you are done with that one. When I come to this one with a -4, still I say the original function is this. Now, where there is x, I'm going to put a -4, as you see. I'll be having -4, now square minus 2 over -4 plus 1. Where there is x, I put this, and here I suppose the same. When you square negative, when you square any number, we get a positive. So when I square -14, I get -4. I get 16 minus 2, -4 plus 1, get -3. And this will be up, we have 14 over -3. Multiply by negative up and down, end up -14 over 3. So that's how we can easily evaluate functions with ease. I will see you.